Hello, this is going to just be a quick little video to go through what we did in class on Monday, September 28th. And our topic today reviews some stuff that you should have done before, but we're going to double check and make sure that you do remember everything. We're talking next about proportions. And this goes on with the rest of chapter 2 after basic equations. It tells you a proportion is just an equation that says that two fractions are equal. You always have fractions, and in fact, pretty much everything else we'll do in chapter 2 is going to somehow involve fractions. So it might look something like 3 over 5 equals 6 over 10, or you could start throwing variables in there, which is what we'll actually care about. You could even have an expression that has a variable in it as part of your proportion. You can also have proportions that don't have literal fractions. They have ratios like 1 to 5 equals 12 to 180. It's the same type of thing. When we work with proportions in algebra, we're going to care about ones where you actually have a variable in the expression. If you don't, it pretty much just boils down to reducing a fraction, and that's why we care about what's x in situations like this. Now, you probably remember from things you've done before that the way we solve problems like that most often is called cross-multiplying. What you literally do is you think, what do you get when you multiply diagonally both directions? Like here, in 21 over 72 equals 28 over x, I could think that's going to be the same as 21x equals 72 times 28, which happens to be 2016. You divide that and you come up with your answer, which happens to be 96. Here's another problem that's basically the exact same thing. 3 times x equals 30 times 2. And when you get done, the answer's got to be 20. Now, most of the time, if I was looking at a problem like this myself, I would not bother writing out the equation 10x equals 6 times 25. What I would do is I'd haul out my calculator and just multiply and divide. 6 times 25 divided by 10. And you're going to come up with an answer of 15 if you do that. If you think about it, the equation would be 10x equals 150, so you'd have to divide by 10 to get the answer. You multiply diagonally one way, and then you divide by what's diagonal from x. So take just a second and see if you can solve this problem. And if you do it correctly, you should get 21 divided by 8. You can just write that as 21/8, or as a decimal, it's 2.625. So again, anytime you've got like x over a number equals some fraction, you can just multiply and divide to come up with your overall answer. Slightly more complicated when you have something besides just x in the fraction, when I have a problem like this one. When we did this in class this morning, we had 2 or 3 different correct ways that you could come up with the answer on this. What I'm going to do is give you something that will always work, and it really just boils down to cross multiplying like I told you before. What you're basically going to do is take 3 times 2x plus 3, and that equals 9 times 7, which is 63. The important thing on this is I've got to actually distribute the 3 times both 2x and 3. So I get 6x plus 9 equals 63. If I was solving this myself, I probably wouldn't bother writing down the first line I have here, but I would write down everything else after that. I'd write down 6x plus 9 equals 63 and then solve that equation and get 9. So again, let's see if you can solve a similar problem to that and come up with an answer. In this case, you would cross multiply. We're going to get 10x plus 20 equals 450. You'd have to subtract 20 and divide by 10, and indeed you do get 43 for the answer. Here's one more that you can take a minute and see if you can cross multiply and come up with a correct answer. And it turns out that what we're going to end up with is 2 and 1/8, there's 17/8, 2.125. Again, you've got to basically take the 2 and distribute it times 4x minus 1, and then solve the equation that's left after that. So pretty much any proportion you want to solve with cross multiplication. We're going to also take a look at how you can solve story problems that involve proportions, and they're pretty straightforward to solve. We'll look at a couple of examples today of that. Our first one says, when a car dealer sells a $19,000 car, he makes a profit of $2,850. So at the same rate, how much profit would they make on a $24,000 car? If I want to solve a problem like this myself, what I usually do is read the first sentence, and then I make a fraction out of those numbers. So like 19,000 over 2850. Then I think, what order did I write things down in? I put the price of the car on top and I put the profit on the bottom. So I'm going to set that equal to the price of the other car and the profit I would make, which is what we're trying to find. Again, here I'd cross multiply 2850 times 24,000 divided by 19,000, and we end up with an answer of 3,600 bucks. There are multiple ways that you could set up the equation for this one. I could have, for instance, said something like 19,000 over 24,000 equals 2850 over x. What's important is that both when you look at the fractions up and down and when you read across the equation, the numbers should have something in common. Like on top of the fraction here, I have the price of the two cars. On the bottom, I have profit. The first fraction here talks about the first car, second fraction talks about the second car. As long as you got stuff in common both ways, you're going to end up getting a correct answer with it. See if you can set this one up and come up with an answer. You might want to pause the video until you have an answer. And if you do it correctly, what you're going to end up with is something like 4 over 3, because the ratio of, in this case, one sex to the other is 4 to 3. We had 20 girls, which is going to go on the bottom, so x over 20. I purposely did this one so if you cross multiply, it doesn't come out even. And that's okay because we just round to the nearest whole number. Here it would be 27 boys. Here's one more problem. There were 36 problems on an assignment, and it took John 90 minutes to do that assignment. If another assignment had 20 problems of similar difficulty, how long would it take John to do that? There's actually a question on the STAR test that's a lot like this one. So let's see if you can set this up and do it. Again, you might pause the video and then come back. And here's what we did. We had 36 problems on the first one, 90 problems on the second. It took 20 minutes to do the first one, or excuse me, 36 problems took 90 minutes, so 20 problems would take how many minutes? And when you cross multiply, it should be 50. Going along with those, there's one other term that we're going to talk about quickly today. You'll learn much more about it next year in geometry class. The term similar just means the same shape but different sizes. Like these triangles and these trapezoids would be pairs of similar shapes. You also have things like the trees and the giraffes are the same shape but different sizes. And it's actually the idea of similarity is the reason why I have the Pepsi stuff you see behind me in the little inset is here. And that's because you can have things like different cans. I have things like this little can that I could put out in front of me that's similar to a normal can of Pepsi, but it's smaller than a usual one. This one, by the way, I happened to get in England years ago, and it's probably per ounce the most expensive can of Pepsi I ever had. It cost £1.50, which is almost $2, just for a little teeny tiny can of Pepsi. This turns out the symbol for similar is just a little squiggle that looks like it belongs in Spanish class. But the thing that's important about similarity is that corresponding sides in similar shapes always are proportional. If you look at the two triangles that I have there, the triangle on the left and the triangle on the right, each side that's in the same place is twice as long in the big one as it is in the small one. So they've been increased by the same amount. They're proportional. Sometimes you'll see pictures where they'll show you some parts of similar shapes and you're supposed to find what's missing. You can see that to solve this one, they did the diagonal side of the big one over the vertical side, x over 6. And they said that's equal to the diagonal side of the little one over the vertical side of it, 1 over 1.5. You'd cross multiply, and they figured out that the missing side has to be 4 feet long. All you're doing is making the fractions by matching up stuff that goes together and then cross multiplying to get the answer. That's exactly what you would do in this one as well. Here they put 3 over 8. Again, just looking at parts of the smaller of these parallelograms. That's going to equal x over 16, the sides that are in the same places for those. And when you solve it, you end up with 6 inches for the top of the big parallelogram. Sometimes there's more than one way you can do a problem. When I showed this one to my class this morning, several people immediately knew that the answer had to be 20 or 20 meters. And all they'd done is they'd realized that the bottom of the big triangle is 10 times as long as the bottom of the short one, so the height's got to be 10 times as much. And that's exactly correct. You can also solve that by setting up a proportion. And if you do that, you're going to cross multiply. You would end up getting, in this case, 60 divided by 3, which is 20 meters. I'm going to look at one last problem here. This one is sometimes a little bit more complicated for people to do, just because you got to be careful of what you're matching up with what. On this one, it says find the value of the height h, and they tell us that we have a net that's 0.9 tall, and we have one side that's 6 and one side that's 12 meters. Well, what you got to be careful of here is that you're looking at sides of triangles when you put things together. And most people realize you're going to have something like 0.9 and h will go together. But what can be harder to realize is that the 6 is going to end up going with 18 rather than with 12. You've got to actually add the stuff up to come up with it. And what I would do to solve this now is take 0.9 times 18 and then divide by 6 to figure out what my height is overall. Now, that's just a real crash course. Today, there was no assignment in class, but tomorrow they're going to be doing some problems that involve solving proportions. So that's where we're at in algebra class.